Hello everyone. Here we will discuss about 15 puzzle problem which is invented by the scientist Sam Lloyd on 1878. This 15 puzzle problem board is having 15 numbered tiles which are placed on a 4 by 4 frame. Okay, so here the tiles are numbered for each and every slot. The initial state arrangement for the given frame having the shuffling of the tiles. The goal state is here we have to arrange this given tiles in the frame into sequential order, that is in ascending order. So here the 15 is available in the first slot, but we have to arrange that all the numbers given in the frame into sequential order, like ascending order 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. The this empty slot should be at last, so this is numbered as 16, right? So here the objective of this puzzle problem is we have to transform any initial given arrangement to goal arrangement through the series of legal moves. Here the legal moves are left direction, right direction, up and down direction. What is the legal move? Moving a numbered tile which is adjacent to empty slot. For example, here we are having 11 is adjacent tile, 10 is another adjacent tile, 7 is another adjacent tile to this empty slot. So we have to move any one of the tile into this position. That means we have to move this empty slot into left side or upside or downside. So when you are moving this empty slot, automatically that numbered tile will come into this position, the empty slot will go into that numbered tiles position. By sequence of legal moves, finally we have to reach the goal state, that is having sequence of numbers arranged in ascending orders. Here the state space tree is used to reach the goal state with minimum time complexity. The solution is the path from initial state to the goal state. That means we will have the initial state, then we have to go on sequence of movements of this each and every tile to reach the goal state. So when you are moving the tiles to reach the goal state, you will have some path. That path is the solution. Here the frame is having 16 tiles, so there is the possibility of 16 factorial different initial arrangements of these tiles. For example, here this is one kind of initial arrangement. By shuffling these tiles, you will get different tiles, a different set of different type of initial arrangements. So how many possible arrangements? 16 factorial. In this 16 factorial different arrangements, only half of them are reachable to reachable to the goal state from any given initial state. Suppose if your initial state is different initial state than this one, there is the possibility of not reaching to the goal state. Okay, so that kind of initial arrangements are 16 factorial divided by 2. So that means only we can reach 16 factorial by 2 number of initial arrangements to the goal states. Remaining 16 factorial by 2 arrangements cannot reach into the goal state. So here the tile position are numbered as 1 to 16. The position of I, for example, here this is numbered, this position of 15 is given here. So position of 15 is now 1, position of 2 is now 2, position of 1 is now 3, position of 12 is now 4. So like that, which is having the position. But the goal state, in the goal state, the position of 1 should be in the 1, position of 2 should be in the 2. Likewise, the position of 15 should be in the 15th position. The empty slot should be in the 16th position in the goal state. Here, whenever we are getting the initial state, so this is one of the initial state. So how can we identify this initial state is reaching to the goal state? That means here, as per this statement, here only 16 factorial by 2 number of initial arrangement will reach the goal state. Remaining 16 factorial divided by 2 number of arrangements cannot reach to the goal state. That means we cannot arrange that 16 factorial by 2 number of tiles into the this particular sequential order. So how do we identify at the initial position itself, either that given initial state is leading to reach the goal state or not? So for that, there is 15% theorem available, which is identified that Sham Lloyd. So here we have to identify the less of each and every tile. Okay, that means we have to identify the, suppose you take the number 3. So here the number 3 is the tile number I. Then we have to identify the position of the I. Position of I is here 2. Okay, so here the position of I given to the number which are less than the 3. So less than the 3, we are having two possibilities, 1 and 2. So these two tiles are less than 3. So we have to check these tiles are correct, placed before the 3 or after the 3. So here 1 is placed before the 3, but 2 is placed after the 3. So we have to count number of tiles which are less than the given tile I. Okay, the number of tiles which is less than the 3 placed after the position of 3. So after the position of 3, we are having number 2. So this is the less of 3. So number of tiles is here 1 number of tile, that is 2 placed after the 3. That's what given here. The uh, j number of tiles, that means count of the number of tiles. So j number of tiles such that j is less than I. So here I is 3 but j is 2. Okay, so here the position of j is greater than position of I. You look at that, position of 2 is here 5. Position of 2 is here 5, greater than position of 3 is here 2. So you look at that, this 5 greater than 2, that means how many number of tiles are positioned greater than that tile I. So that is the meaning of less of I. Then r equal to 1 here, that means the empty slot, this one is placed in shaded position or unshaded position. How do I identify shaded position and unshaded position? The reference for the r is given there. So from this reference frame, we have to identify where is that this 16th tile, that means empty slot tile is placed. You look at that, the empty tile is placed in this location. So this location is unshaded position. If the 16th tile empty slot placed in unshaded position, then that value is 0. So we have to substitute here r value is 0. Otherwise, if empty tile is placed in any one of this shaded position, then we have to give here r value equal to 1. So that is the thing. So here when you are substituting the values after calculating the position of each and every tile by calculating less of each and every tile, then we have to check that the summation of all the less of I plus that r should be even. If it is even number, then we can say that given initial state is leading to reach the goal state. Otherwise, if we get any odd number, then the given initial state is not leading to reach the goal state. Now we will see example here. So this is the given initial state. Here the 16 is placed in the position here 6. Okay, in the initial state. A reference frame also given for identifying the position of 16. So now the formula as per the 15% theorem is the goal state is reachable from the given initial state if and only if the summation of less of all tiles plus or is should be I mean is even. Okay, so now we will calculate less of 1. So here less of 1, any number less than the 1 in the given frame, no tile is less than 1 which is placed after this 1. So here no tiles are less than 1 which are placed after this 1. So here which the count of number of tiles which are less than 1 are placed after the 1 is 0. Then come to the less of 3. Here the less of the for 3 we are going to calculate the how many numbers less than 3. One is 1 and another one is 2. So one is less than 3, so one is placed before 3, so it is not at all a problem. Then 2 less than 3, so here 2 less than 3, but the 2 is placed after the 3. That means position of 3 is here, position of 3 is here 2, but the position of 2 is here 5. So 5 greater than 2, so it should not be like that. So always position of 2 should be less than position of 3. So how many tiles are available in this case? Only 2 is available for this 3. So number of tiles which is less than 3 placed after the 3 is only 1. So that's what given, less of 3 equal to 1. Then less of 4. Again when you are calculating for less of 4, here the less of 4 is here. So how many possibilities are there for the 4? 1 is less than 4, 2 is less than 4, 3 is less than 4. So 1 is placed before the 4, so it is not need not to count. And 2 less than 4, so here 2 is placed after the 4, so we have to take as a count less of 4. Then here 3 less than 4, here 3 is placed portion of 3 is less than portion of 4, so need not to count this one. So we have to count only 2 which is positioned after the 4. So that's what we are taking. Tile 2 is less than 4 which is counted because it is position is greater than the position of 4. Then we are taking the less of 15, next one. So when you are taking the less of 15, here the 15 is placed, position of 15 is here 4. Okay, but when you are taking that position of all other tiles, okay, position of 15 is 4, all other tiles position of 2, here position of 2 is here 5. Okay, so position of 2 is 5, so 5 greater than 15, so we have to count this tile. So like that the here the 16 is placed after the 15, so no need to count this. Next one is 5. 5 is less than the 15, but the position of 5 is greater than the 15. Okay, so we have to count that also. Then position of 12 is here 8, so 8 position of 12. Then position of 15 is here 4, so which is again greater than 4. So the position of 15 is less than the this one, so we have to count 12 also. Like that when you are checking all other elements, 7 is also placed after the 15, 6 is also smallest number but placed after the 15, 11, 14, 8, 9, 10, 13, all the elements are less than the 15, but the position of these smaller elements are greater than the 15. So we have to count all elements. So less of 15 is 11. Then less of 2 here. So when you are taking the less of 2, only one possibility, that means 1 is less than 2 but which is placed before the 2. So position of 1 is less than position of 2, so no problem at all. So but there is no tile which is having that condition, so it is which is 0. Then position of I mean less of 16. So less of 16 here, this one So we have to check. So all elements are smaller elements than the 16, but the position of all the elements are greater than the position of 16. So position of 16 is here 6, all elements are after the 6 only placed. So we have to count all the values, that is number of tiles are 10. Then less of 5, so 5, after the 5 is there any element? So 5 is having 4 possibilities: 1 less than 5, 2 less than 5, 3 less than 5, 4 less than 5. But all 1, 3, 4, 2 are placed in front of the 5. That means position of all these elements are less than the position of 5. So we need not to count. So it is 0. Then position of, I mean less of 12. Less of 12, when you are taking, you look at that the position of 12 is here 8, but position of 7, 6, 8, 9, here 11 and 10. So 6 elements are position of these 6 elements are greater than the position of 12, that is 8. So we have to count all the 6 elements. Like that, when you are calculating for the 7, after the 7 smaller element is 6, the position of 6 is greater than the position of 7. So we have to count that one. So 1. So less of 6, here after the 6 there is no smaller elements, so 0. After the 11 we are having 3 smaller elements, 8, 9, 10. So position of these elements are greater than the position of 11, so we have to count all 3. Like that, 14 we are having 4 elements, position of all 4 elements are greater than 14, so we have to count it. So like that, 8, 9, 10, 13. So for after 8, 9, 10, 13, no smaller elements, so all are zeros. So now what is the position of R? So here R is the empty tile. So empty tile is placed in shaded position or unshaded position. So this is placed in unshaded position. If it is placed in unshaded position, then R value is 0. So now we have to add, all the values here. So these are the values: 0 plus 0 plus 1 plus 1 plus 0 plus 0 plus 1 plus 0 plus 0 plus 0 plus 3 plus 6 plus 0 plus 4 plus 11 plus 10. We are getting here 37. By adding R value here is 0, right? So here you are getting 37. So this value is odd number. If it is odd number, then we cannot reach to the goal state. If it is even number only, we can reach. So from this given initial state we cannot reach to the goal state. So what to do? We have to kill this particular node. We should not use this node to go ahead, that means to reach the goal state. So here itself you can kill this node. No need to explore this particular node in the state space tree to reach the goal state. And another example here given. So is this able to reach into the goal state or not? So here the 16th empty slot is placed here. Now I am finding, as per the calculation, less of 1. Less of 1 is 0 because there is no element, smaller element after the 1. 2 also correctly positioned here. The 1 is positioned before the 2, so no need to count. For 3 also, here 1 and 2 are placed before the 3, so 0. The position of 4 is also greater than these 3 possibilities, so which is also having 0. Less of 5, 6, so both are having 0 because 5 and 6 are having these possibilities. All are before, I mean position of these elements are less than the position of this one. Now position of 16, here is different. So we have to calculate the less of 16. So we are having all are smaller elements here, 9 elements. So 9 elements are smaller elements, but position of all 9 elements is greater than this position of 16. So here 9 is the less of 16. Then we have to identify 9 and 10. So for 9 and 10, again we are having smaller elements, 7. Okay, so here the position of 7 is greater than the position of 10, so which is 1. So 9 and 10. So then 11, there is no smaller elements after the 11, so which is 0. For 12 also there is no smaller elements after the 12, 0. For 13, 14, 15, we are having smaller element 12 after this element, so position of 12 is greater than the position of this element, so all are having less of that particular I is 1. So finally we have to find out the empty slot position is shaded position or unshaded position, which is shaded position, so r equal to 1. We have to substitute all the less of that tiles. When you are substituting, you are getting the 16, which is even number, so this initial state is leading to reach the goal state. So you can explore this node to reach the goal state further. Thanks for watching.